Okay, we are continuing on with our stoichiometry notes. Today we're going to learn about what is a mole ratio and how to apply it to solve problem type 1 stoichiometric problems. Okay. This is about relationships.
We can't see
That would help. Okay, bloopers. Bloopers. I need a dot camera. You can hear me, but you can't see me. Okay. Thank you. Oh, we keep going. There's nothing like good, friendly bloopers. Everybody enjoys bloopers, don't they?
Yes, ma'am. I do.
Okay.
I like the way you say that.
Okay. Now, let's see if we can try this again. I think it's all still working. And bloopers and all. Okay. All right. So, first off, we're going to look at relationships. And I'm going to write fast, and I expect you to write fast. Relationships derived from a balanced equation. Relationships derived from a balanced equation. So this is just to clue you in. There are 6 relationships that you can see from a balanced equation. So, what are they? First one, a word equation. Okay, so we're looking at iron. Start off with a word equation plus oxygen produces iron 3 oxide. Okay, so everything starts off in words, so to speak. From the word equation, we can write a chemical equation. What's the symbol for iron? Plus, symbol for oxygen? O2. Everybody remember, by themselves. The Magnificent 7, please. And iron 3 oxide is Fe2O3. Oxygen's a -2, iron's a +3, crisscross, and you see the formula. Alright. Now then, need to balance it. How many irons on the left? Left? Over here? Okay, but before I even do that, I see something that just caught my eye. Odd man, even man, so right off the bat I'm going to put a what? A 2. Now I need how many irons?
4.
And I need how many O's? For 6 total. Okay, there it is, balanced. Alright, third. Those coefficients tell you several things here. One is the number of individual particles. This is telling me how many atoms of iron? 4. Okay. Plus how many molecules of O2? So we're looking on the individual basis here. And how many formula units of Fe2O3? 2. Okay. Now we're going to look at it as the number of moles. So those coefficients play different parts. If you're talking about individual atoms, molecules, and formula units, okay, those are individual particles. Now then, we're going to look at it as number of moles. So there's how many moles of Fe? In our original reaction there, how many moles of Fe? 4 mole of Fe. Plus how many moles of O2? Read the coefficient. And it produces how many moles of Fe2O3? Okay, if we're learning about mole ratio, what are we going to be talking about today? Number of what? Yes. Okay, the fifth relationship is mass in grams. Okay? And this is coming from yesterday's work, kids. If you look back for the iron, what was the mass in grams of the iron? Go look back on your previous notes where we did the molar mass conversion of the iron. You see 223.38 grams? Okay, so 223.38 grams of iron plus 95, all these numbers are coming from yesterday, 0.944 grams of O2 and 319.374 grams Fe2O3. Okay? So 6 is the law of conservation of mass. And remember, we proved that where we ended yesterday. The total mass of the reactants was 319.374 grams for the reactants. And it's exactly equal to 319.374 grams for the products. Okay, all of these relationships come from a reaction. Okay? Questions?
Will the reactants and the products always equal to each other?
The mass in grams, absolutely. Because it's a balanced equation. And I want to take you back and look at this. Do you see that we have 4 irons on the left? And we have how many on the right?
4.
Okay. We have 6 O's and we have what?
6.
So it can't help but be equal. Does that make sense? Because we have identical number of elements on the left that equal the same number of elements on the right. And so when we do the molar mass, it comes out equal. Does that make sense?
Yeah, I just don't understand why we do the law of conservation of mass if we know it's always going to be equal.
Well, it's not equal. This is just proving it. It's not equal until you have a what equation? Balanced. And that's why this is important. If you look back at the first of your notes, you have to have what kind of equation to do stoichiometric problems? Balanced. Okay? Good question, honey. These are just all relationships, and one that you have to know is that the law of conservation of mass. So when you have a balanced equation, the mass on the left is always equal to the mass on the right. Okay? All right. Mole ratio. Here we go. This little section's called the mole ratio. Definition. Mole ratio. A conversion factor that relates the amounts in moles of any two substances involved in a chemical reaction. Star. I wonder why I put that. The mole ratio is the only thing and underline only you can use to convert from one compound to a completely different compound Thank you, sweet. Yeah. Thank you. To a completely different compound in the reaction. Okay, everybody finish and then get your heads up because I need to speak about this. Okay, when we've done different things with the mole and grams and stuff, molar mass, whatever compound we started out with, we finished with. Okay, how is stoichiometry different? In stoichiometry, you change from one compound to a different compound in your reaction. Okay? So what this is telling you up here, the only thing that you can use to go from one compound to a different compound that's in your reaction is the who? Mole ratio. Nothing else can change you. Nothing. Okay? So this is vital that you get that. Okay, so reaction. We've got 2Al in the solid form plus 3Br in the liquid form, arrow, 2Al Br3 in the solid form. Alright, so there's our reaction that we're going to work with. Okay, it says write all the mole ratios that can be written from the balanced equation above? The number of ratios possible is the total number of the reactants plus the total number of products added. Whoa, 2 D's. Blooper. Added together times the total answer minus 1. Okay. Example. Okay. How many reactants are here? 1, 2. Everybody see that? 1, 2. This one plus that one. Plus the number of products. So we have a total of how many things in this reaction? 3 different things, yes? Okay. So 2 reactants, I'm doing this so it's extremely explanatory, plus 1 product equal a total of 3. Okay? So 3 times, now look what I'm going to do, times the total answer minus 1. So 3 times 3 minus 1, which is what? 2? Okay. Equals a total of 6 possible mole ratios. So this tells you how many you have to have. Does that make sense? Okay. So now this is where I want you to pay close attention. Now, how many of you have kind of recognized that I'm a very systematic person? Okay? Everything I do, I try to make it flow as easy as possible in your notes. And I go to great detail, okay, on how to do things. Now then, in a mole ratio, you start at the beginning, and I always put my finger on it to know that I've covered. And a ratio is written as top over bottom, yes? Okay, so I have how many moles of Al, kids? So I write 2 mole of Al, and then I put it on top to everything else in my reaction. Can y'all, yeah, you can see me. So 2 mole of Al to what? 3 mole of Br. And I'm still, this one is still on top. So 2 mole of Al to what? This one right here. Yes, to 2 mole Al Br3. And I don't want you to reduce these down, even though they can. Sometimes I think it can confuse you. Okay? So we're leaving them as is. Alright, so I've done all the mole ratios with this one on top. Ah, you can't see me. with this one on top. Now I'm going to move over, and who's going to be on top to the 2? The 3Br. So I have 3 moles of Br to what? 2 moles of Al. I know you can't, but I can't seem to get, let me go down smaller so I can get it on the screen at the same time. There we go. Okay, so I'm putting this one on top, so I've got it 3 moles of Br to 2 moles of Al, and then I've got one more to do with it on top. 3 mole Br to 2 mole Al Br3. So we've done 4. Now this one is going on top to the other 2 on the left side, yes? So my last 2 are 2 mole AlBr3 to 2 mole Al and 2 mole AlBr3 to 3 mole Br. And that way I know I have all 6. Okay? So those are all the 6 possible mole ratios that you can get from this reaction up here. Okay? All right. Now then, on your test, you think this is important? You can see mole ratios written in this form. Okay, in our math, what we're getting ready to do, this is the way we will write our mole ratios. But on a test, they can ask you, what is the mole ratio of aluminum to Br? Everybody with me? So I've just posed you a question. What is the mole ratio of aluminum to Br? You can see it written as 2 to what? 3. Okay? What is this mole ratio? Okay, and this one? You always have to put the one that they're asking you about first in the front. Does that make sense? So what is the mole ratio of Br to AlBr3? 3 to 2. And what's this one? And if I asked you what is the mole ratio of AlBr3 to Br, you would say, okay. So the one they ask you first always has to go in the front. All right? So be sure you understand that. Okay. Moving on. Getting to the nitty-gritty now. Anybody have questions over how to write mole ratios? Okay, problem type 1. How am I doing on time? Oh, good. Okay, problem type 1. Problem type 1. Problem type 1. Given, also known as the known, and unknown quantities are in moles. Okay, so on problem type 1, do you ever leave moles? No. All work is done in moles. Okay. So basically you are converting from the amount of given substance in mole which is also called the known, to amount of unknown substance. In mole. So that's the gist of it. Okay? Your setup will look like this. The given always goes in what box? And you'll have mole of known on the bottom because whatever unit is here has to go where? And then the mole of the unknown on top to end in mole of unknown. This is your mole ratio right here. And this is your given in the problem. Only number given. Okay? Your only number given goes in your given, which you already know. So mole, and then this is your mole ratio. So in your mole ratio, now please listen, the mole of the known is always going to be on the what? Bottom. Who you're switching to will always be on the top. All right. Very important. The numbers used in the mole ratio please star this. Oh my goodness, I have seen people that never get it. The numbers used in the mole ratio come from the coefficients in the balanced equation. Coefficients. Somebody tell me, what is the coefficient in a balanced equation? The big numbers in front. Everybody understand? Okay. All right. So, okay. Example. Here we go. How many moles of ammonia which is NH3 are produced when six mole of hydrogen gas reacts with excess nitrogen? Okay. First thing you have to do is underline and identify the known and the unknown, or the given and the unknown. Which way do you want me to talk? You want me to talk about it in terms of known and unknown? Okay. What do we know? 6 mole of who? Okay, this is our known. All right. Go to the word that says how many. Everybody see it? They want us to find moles of ammonia. This is our unknown. Everybody see that? Okay, critical that you underline and identify. All right, the reaction is 3H2 plus N2 produces 2NH3. It's already balanced for you. I've balanced it. Okay, we have identified. Here's our balanced reaction. So, in my little box, what goes where? 6 mole. That's my given. You never change what they give you. That's written in stone. 6 mole of H2. Everybody agree? Okay. Now then, this is my what ratio? And we are switching from hydrogen gas to what? Ammonia. So down here, if I have mole of H2 here, what must go here? And who am I switching to? Mole of NH3. That's right, mole of ammonia. Okay? Now, read this. What does this say? Okay, so I go to my hydrogen. What's my coefficient in front? So I put a 3. I go to my ammonia, and what's my coefficient in front? And I put a 2. Do you see that this is not like molar mass or any of those where 1 mole equals a certain number? So we will not, it's not an automatic 1. Does everybody understand? Because you are reading the coefficients. Okay? All right. Simple enough. Moles cancel. Now it's left to do the math. 6 times 2 is 12. Everybody agree? Divided by 3 is what? So my answer is 4 mole of NH3. And you're done. I call these one-steppers. Why? There's only one vertical line. Does everybody see that? Now when we start going to the other tops, they will be called 2-steppers and 3-steppers. Yes? All right. So, do I have time to do one more example with you? Yes, I do. Don't you think you need as many examples as possible, maybe? Okay, your homework is on the back. They're all same type of problems. Does everybody understand that? Problem type 1. Okay, so I'm going to do one more with you. Huh? Yeah, I don't have one. Let me go get one. Okay, I gave you my own notes. You can read through this if you so desire. Okay? Otherwise, skip it and just do the work on the back. Okay, homework, problem type 1. Here is your balanced equation. Everybody see it? Now then, it says, go straight and go find the number. See how easy it is to pick out your known? 6 moles of who? Now, I found this out helping somebody that wasn't going to be here today. They couldn't identify who potassium chlorate is. Can you? KCl is potassium chloride. Remember, polyatomics end in ATE and ITE. Everything is coming back to bite you. Naming. Binary compounds end in IDE. KClO3. Yes. Everybody see it? Chlorate. Polyatomic. So you might want to have your polyatomic sheet handy. You need to remember, binary is IDE. Polyatomics are 8s and 9s, aren't they? Okay, so this is our known. Go to the how many. How many what? Of oxygen is our unknown. So that's who you're ending in. Okay, so I write down my given, my known, 6.25 mole. Potassium chlorate is KClO3. Okay, and by the way, I'm going to grade this box by box. You must have a number, a unit, and who it is. Number, unit, and who it is. Each box is going to be an X. Number, unit, and who it is, and your answer, number, unit, and who it is. Everybody get my drift? Okay.
Are these the questions already balanced? All of them?
Yes. They're all given to you and already balanced. So, I go look what number's in front of KClO3.
2.
So 2 mole KClO3, and I go to my oxygen, and what's in front of it?
3.
And you can see that mole of KClO3 does what? All right, so 6.25, let me get my handy dandy calculator here. Did you do it? 6.25 times 3 is 18.75 divided by 2, and we get 9.375. How do you want to do your answers, kids? Okay, now, I don't think they will come out very long decimal places. So let's keep at least 3 decimal places, okay? If they come out and run you out 6, 7, 8 decimal places, round to 3, all right? All right, now what do I put on the end? Okay, what do you have to have in every box? Number, unit, and who it is. Okay? All right. Now then, is this easy or what? It is very easy.